Okay, in this first section, we're asked to complete each statement to make it true, and there may be one or more correct responses. So number one, the tangent of x and the sine of x, parent graphs, have the same what? So tangent is sine over cosine. The tangent of x equals the sine of x divided by the cosine of x. And since sine is in the numerator, that means that the zeros of tangent and the zeros of sine are going to be the same. When we look at their graphs together in Desmos, y equals sine of x and y equals tangent of x, we can see here at their intersection, right, they have the same zeros in common. Okay, they also have the same y-intercept. So those would be two features that would be in common to both. So tangent and sine have the same zeros and the same y-intercept. Okay, number two asks the parent graphs of secant and tangent both have what at pi over 2 plus or minus k times pi. Secant of x is the reciprocal of the cosine. And the tangent of x, we already saw, is sine over cosine. Since secant and tangent both have cosine in their denominators, that tells us that wherever tangent's asymptotes are located, secant's asymptotes will be the same. And those asymptotes will occur at the zeros of cosine because you can't divide by 0. So when we look at our graphs for secant and tangent, we can see here at pi over 2, there's a vertical asymptote that they have in common. Then again at negative pi over 2, at negative 3 pi over 2, and so on, these two functions have the same asymptotes. Then number 3 is asking us to compare secant with cosecant. And when we look at their graphs, secant of x and cosecant of x, okay, they both have the same shape. They're alternating U shapes. They have the same magnitude of their extrema. So the relative minimum of both secant and cosecant is 1. The relative maximum of secant and cosecant is -1. The locations of those extrema with regard to the x-axis are different, but the y values of those extrema are the same. And then another comparison we can make between secant and cosecant is their range. The domain is different because their asymptotes are at different locations, but they have the same range because they have the same gap in between their extrema. So the range for both is -infinity to -1 with a bracket union and then a bracket at 1 up to +infinity. So secant and cosecant have the same range as well as the same magnitude of their extrema. Number 4, the reciprocal graphs of sine and cosine. So the reciprocal of sine is the cosecant and the reciprocal of cosine is the secant. So we'll be looking again at the same graphs from number 3. And when we look at those in Desmos, we see that they are the only parent graphs that don't have any zeros, right? This gap in the middle means they don't intersect with the x-axis, so they have no zeros. Okay, then number 5, the relative maximums of blank are the absolute minimums of sine. So when we look at our graph in Desmos, if we graph the parent graph of sine and its reciprocal cosecant, we see that the relative extrema of the cosecant are the absolute extrema of the sine graph. So that would be the relative maximums of cosecant are the absolute maximums of its reciprocal sine. Okay, number 6, the zeros of sine are the asymptotes of what function? So in order for there to be asymptotes, the sine function would need to be in the denominator, and that would be the cosecant. Right? Cosecant is 1 over the sine. So cosecant would have its asymptotes where sine has its zeros, and that would also be the case for the cotangent function, because cotangent is the cosine divided by the sine. So again, the sine is in the denominator, and since you can't divide by 0, anywhere that sine is in the denominator, we're going to have asymptotes. So the zeros of sine are the asymptotes of cosecant and they're the asymptotes of cotangent. Okay, number 7, the sine curve phase shifted left by pi over 2 is the same graph as the parent graph of what function? So back to Desmos again, here's our sine graph, and if I look at the graph that has the same shape, right, that would be the cosine graph, and notice that the y-intercept here for the cosine is pi over 2 units away from the corresponding point for the sine function. So the answer then to number 7 is cosine. Right, those are co-functions, so they're pi over 2 units apart. Okay, the only 2 parent graphs with no blank are cosecant and cotangent. So when we look at Desmos again, we'll graph the cosecant and the cotangent. Get rid of the cosine here. And the cosecant and the cotangent do not have a y-intercept, right? All of our other parent graphs have y-intercepts except these 2, because these 2 have vertical asymptote along the y-axis. So we have no y-intercept for cotangent and cosecant. Then number 9, sine and cosecant intersect at the point pi over 2 comma blank when graphed together. So when we graph sine and cosecant, we see here at pi over 2 comma 1, those 2 graphs intersect. So the point pi over 2 comma 1.